Now I'm going to enable eigrpv6 on router. So let's remove the configuration on all my router. First of all, I should go to configuration mode. I should go to interface layer fast00, no IPv6, rip, e-money, enable, and I'm going to have this on serial 00, on fast01, and on loopback 0. And in global configuration, I'm going to remove IPv6, router, rip, e-money. And now that I have done this, I'm going to copy and paste this line of command on all my routers. So remove rip configuration on all my routers, and let's go back to eigrp. Now if I want to add eigrp support, I should note something very important. First of all, I add IPv6 router eigrp, and you can see that I should add an AS number here, for example AS number 1. And the first thing that you should know is this: eigrp process is by default shut down. So first of all, under router configuration, you should add this command, no shutdown, and eigrp process now is working. And now you can go under each interface and add this line of command, interface fast00, IPv6, eigrp, and now you should give the process number, AS number of course, and that's it. There is no enable here. So I go to fast01 and add this line of command. I go to interface serial 00 and interface loopback 0 as well. We'll have this. So let's go to router 2 and add the same commands and see the neighborship coming up. If I go to router 2 and go to IPv6 router eigrp command for AS number 1, and first of all I should no shut this. I go to fast00 and I add IPv6 eigrp1 and hit enter, and after a while I should see the adjacencies coming up. And you can see that neighbors use link local IPv6 address to create neighborship in eigrp. So this is very important. I'm going to show this on serial interfaces to see the importance of this. Let's go to interface fast01 and do this, and interface loopback 0 and do this. And now note, watch this, interface serial 00 is going to have this enabled, and because I have added the correct mappings of these link local IPv6 addresses, now I can have adjacency here. And on IPv6 eigrp, I can see this command, no IPv6 split horizon for eigrp process number 1. And this is the command that I use on multiple interfaces that are acting as hubs in my frame relay configuration. So I added the same command here, and now I have IPv6 disabled here for eigrp process number 1. I have this configuration on router 1. Let's go to router 3 and add IPv6 router eigrp1 and no shut this, and go to interface fast01 IPv6 eigrp1 under interface loopback 0 and under interface serial 00, and this is the most important part, serial 00 interface, and you can see that now I have neighborship. Let's go to router 4 and IPv6 router eigrp1 no shutdown, and interface loopback 0 IPv6 eigrp1 interface fast01 this, interface serial 00, and I have eigrp enabled on all my network. Now that I have this, let's check the routing table and see the lines. To show IPv6 route will give me the routes available here, and you can see that I can access any loopback interfaces as well as other links between the routers. For example, if I want to ping router 4's interface, I can use ping, and you can see that this is reachable. Now the same thing happens whenever you try to use ospf. So I can remove this configuration and add ospf to all my routers. So let's go here, and to do this, under every interface I type in no IPv6 eigrp1, and this is going to change the configuration, and no IPv6 rather eigrp1 is gonna do here. So on router 2 I do the same configuration, router 3 and router 4, and eigrp is now gone. And let's go and enable IPv6 ospf on my routers. So to do this, again, I add IPv6 router ospf, and now you can router ospf, and you can see that I have a process ID that is locally significant. There is no obligation that the router have the same process number. And here I do not need to add any line of command. Actually, like grep, I do not have to put this line of command here because it will automatically be added. But because I want to add a stable router ID to my router process, so I do this. I go add router ID, and here router ID is not going to be an IPv6 address, it's going to be an IPv4 address actually. So I add the loopback IPv6 IPv4 address here for router ID. I go to interface level configuration, fast00, and add this IPv6 ospf, and process number is 1. And next thing, I should actually add the area that this interface is gonna be in there. So this is gonna be in area 0. So I add area 0 for this. I go to interface loopback 0 and add this to area 0 as well. I go to interface fast01 and add this to interface area 12. Now go to interface serial 00 and add this to 1, 2, 3, 4 area. Now I have ospf configured on all my interfaces of router 1. Let's go to router 2 and start configuring here, because again, like eigrp, you can see that linked local IPv6 addresses are so important in creating the neighborship. And interface, let's go to IPv6 router, because I'm going to add the router ID line IPv6 ospf1, and router ID is going to be 151.2.2. Under interface for 00, I add IPv6 ospf1 area 0, and now I should see a neighborship coming up here. That's okay. Under interface loopback 0, I'm going to put loopback 0 under area 0, and in area 0, of course, I'm going to interface serial 00, and this is the most important one. I'm going to add this interface to area 1, 2, 3, 4. And now, because I have the correct mapping in my frame relay configuration, I should see the neighborship coming up. But why there is no neighborship here? This is about the network type that I use. Again, let's see the network type of interface serial 00. So I'm going to show IPv6 ospf, of course, IPv6 ospf interface serial 00 command, and see that the network type is non-broadcast. So either I should use neighbor command under router configuration or change the network type. So I'm going to change the network type to broadcast, for example. And of course, IPv6 OSPF priority is going to be the highest number available, and IPv6 OSPF network type is going to be broadcast. Now that I have this configuration here, I should do the same on router 1's interface serial 00, and now these two interfaces should create neighborship after a while. So I should wait for a second and see the result. Let's go to router 3 and do the same configuration here. I add IPv6 router ospf1 and a router ID 150.133 and go to interface path 0, 1, and it's gonna be under, let's see this, area 13. I guess I have added the wrong area to router 1, so I will correct this. And you can see the serial interface creating the neighborship. Let's go under interface path 01 and change the area to 13. So this is going to be 13 on router 3 under interface path 01. I'm going to use IPv6 OSPF 1 area 13. Now I should have the neighborship coming up after a while. Let's go to interface serial 00 and change this line of command here to change the network type to broadcast and add this to 1, 2, 3, 4 area. Now I should see the neighborship coming up after a while. Okay. And router 4 should have the same configuration. So I add IPv6 router OSPF 1 and router ID is going to be 115.144. Interface path 01 is going to be under IPv6 OSPF 1 area 24, I guess. And I should do the same on router 2. At router 2, interface path 01 is going to be IPv6 OSPF 1 area 24. So I have done this here, or rather 4 I have done this here, and let's go to interface serial 00, the most problematic interface, and I'm changing the OSPF network type to broadcast, and IPv6 area is going to be 1, 2, 3, 4. Now every interface is in its correct mode, and you can see neighborship on router 3 is created. On router 2 I can see the neighborship using do show IPv6 OSPF neighbors, and you can see the neighbors here. Some of these are in two-way mode. That means they are exchanging the database, and now they are in full mode. The other one is XStart. That means I have started exchanging the database. Let's see the command result again. And you can see that this is trying to exchange the database. Now it is not in full mode, and after a while it is going to be full, and that's it. I can see the configuration working here. So I have OSPF configured on all my routers. So let's check the IPv6 route here, and you can see that I have OSPF inter-area links, and I have OSPF links as well. So I should see more links, I guess, here. So yes, it's going to be populated. So you can see OSPF neighbors. And let's go to router 1, see the routing table here, do show IPv6 route. And I have connectivity to different loopback interfaces here. And of course, no, I do not have connectivity to every area. So I should have a problem here, and that's gonna be the virtual link that I have to add to area 34. Of course, I haven't created area 34 here, but some interfaces. I guess on router 3, I haven't added loopback interface to the correct areas. So I add IPv6 ospf area, for example, 13 or 1, 2, 3, 4. That doesn't matter too much. Let's go to router 2 and router 4, of course, and add the loopback 0 interface to this area. On router 2, I should do the same thing. Interface loopback 0 and add this to area 1, 2, 3, 4. And now let's check the routing table on router 1. And you can see that I can access every loopback interfaces right now. Do ping, and everything is working just fine. So now you have a solid, knowledge of what the configuration of IPv6 routing protocols are, and you can configure it on your network.